back to our channel, The Classroom. Today we are back with another chapter of class 8, that is square and square roots. Now, so far we have done the rational numbers, we have discussed about integers, exponents, right? Now, whenever we multiply a number with itself, that gives you the square of the number. You have found out so many times in exponents that a particular digit, that is 2 square, 2 to the power 2, the powers, right? So there 2 to the power 2 was in the form of 2 cross 2, that is 2 into 2, that gave you 4. So this a particular number when multiplied with itself gives the square of the particular digit. Okay, so coming up with all the examples, still what you right now need it. Okay, you have to at least learn those squares for your academics right now. Okay, so I'll just be writing that, you better follow it. Now, I have written the squares of these particular numbers till 25, okay, 1 to 25. This is important. Now, coming up with 1 square it's 1, 2 square it's 4, 3 square it's 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64. Next, 9 square is 81, 10 square is 100, 11 square is 121, 12 square is 144, 13 square is 169, 14 square is 196, 15 square is 225, 16 square is 256, 17 square is 289, 18 square is 324, 19 square is 361, 20 square it is 400, 21 square it is 441, 22 square it is 484, 23 square it is 529, 24 square it is 576, and 25 square it is 625. So you need to learn this much. Okay, rest of the ones you can either like find out by multiplication or estimation, or like using the square root method, division method. Okay, so that we will come to it, but till here 1 to 25 you should learn, because it's not only for mathematics. Now you know that maths is already related with physics, chemistry, everything, right? So you might need it over there also. So it's better to learn up the squares till 25. Okay, if learning more than that, well done. Okay, next, proceeding with one more thing, you might see that if I have written here 0 square equal to 0. Okay, I have just written it. Now, if you see the squaring of the particular digits, you will see some of the numbers are just repeating itself after an interval of time. Okay, 0, 1, 4, 9, 6, unit digits, okay, units place, 6, 5, right? Again, if you leave till here, you will get 6, 9, 4, 1, 0, right? So you can see that some of the digits are repeating itself after a certain period of time, or like certain squaring of the numbers. Like for which are the digits? 0, 1, 4, 6, 9, 5. So these are the numbers which you can see are repeating itself. Okay, in all these cases, not only from here, but you can, if you are doing for suppose 739 into 739, there also you will get the same thing. Okay, so this was a estimation, or like one of the criteria that we have got it from here. Okay, from the squares. Next, one more thing you might find out, that for the squaring of the 1 square, oh my pen's cap, 1 square, then your 9 square, 11 square, 19 square, just see that these all have 1 in its units place. 1 square is 1, right? Again, if you see 9 square, it is again 81, 1 in the units place. Again, if you find out 11 square, it is 121, 1 in the units place. Again, for 19, it is 361, right? So for these numbers, we have 1 in the units place. Means at the last, whenever we have 1, okay, of a squaring, after squaring, if we get 1 in the units place, you might feel that, or you might understand that either it will be 1 square, or 9 square, or 11 square, or 19 square, and so on. Okay, so this is a criteria, okay, that after squaring these particular digits, the units place of these particular digits, the squaring will be 1. Okay, the squaring's number, the result that you are getting, the unit place will be 1 for these particular numbers. I hope I am clear to you. 1, this one, 9, 11 square, 19 square. For these particular numbers, the squaring results, their unit place will be 1. I think you can check it. Oh, another one I have here, that is 21 square. Okay, so these are the criteria. Because you know what? 1 square is 1 and 19 square, if you say that also, or rather 9 square, it is also 81. So we have 1 in the unit place. Okay, so for this reason only, whenever we add 21, 11, 9, 19, for these cases we have the squarings digits unit place as 1. Okay, so these are some of the facts that we have obtained from the squares of the digits. Okay, next. Now, some other facts are, whenever a digit has 0 at its units place, suppose for example I am taking 20, right? Whenever we take the squaring of this particular digit, how many zeros does it have? 1. But after getting the answer, that is the square of 20, we get extra zeros or the same number of zeros multiplied. That is, we have the 20 square as 400, right? So if you are having 1 0 here, 2 zeros will be, that is double the zeros will be added. Next, suppose I am having 300 as the digit. I need the square of this particular number 300. How many zeros are there? 2 zeros, right? So when we will get the answer, that means the 0 that we will be having in the answer will be double than of this. That means it will be 4 in number. So 9, 3 3s is 9 and the zeros will be 4 zeros. So this is a particular answer of this 300 square. I said the zeros will be doubled. Again, take for example 4000, right? So 4000 square, there are 3 zeros here. That means it will get doubled. That means it will be 3 into 2, that means 6 zeros will be there. That means it is 16, 1, 2, 3, 4, 5, 6. Okay, so it got multiplied with 2. So whenever we have zeros, whatever number of zeros in the units, that is in the squares place, that is the answer in the square, the zeros get multiplied by 2. That is, it becomes twice. Okay, I should not say doubled. There is a difference between doubled and twice. It gets twice. Okay, now just to clarify you this doubled, where to use double and where to use twice. Suppose you are using 2 square or 4 square. This can be termed as doubled. Okay, but whenever we say twice, that means 2 into 4 or 2 into b or 2 into 3. This is twice the number. Okay, that means 2 is multiplied with the particular digit. But whenever it is a doubled, that means the same number is multiplied with itself, means squaring. Okay, here also we are doing the squaring obviously, but here the zeros, for the zeros it gets twice the number of zeros in the square results. Okay, now in this chapter of square and square roots, we have one point, that is Pythagorean triplets. Now that is same as your Pythagoras theorem, which we use a right angle triangle for solving this particular theorem. Now in this particular one, we have, suppose this is a right angle. If this is the hypotenuse, this is the base and this is the perpendicular, we already know that hypotenuse square is equal to perpendicular square plus basis square, right? Now suppose this is 5, this is 4, this is 3. Okay, so if we have 5 square is equal to 4 square plus 3 square. Now this 3, that is 5, 4 and 3 are the Pythagorean triplets. Okay, and there are many other triplets like this. 12, 13, 5, 6, 8, 10. Okay, so these all are Pythagorean triplets. You can simply find it out. Here 13 square is 169 minus 144. You get 25. That means 5 square. So this is a Pythagorean triplet. Okay, whichever is under the rule of Pythagoras theorem, okay, follows the Pythagoras theorem, that those 3 numbers are the particular Pythagorean triplets. Right? Next, coming to the square root part, that is specially the long division method. Now the first method of square root we will be doing by prime factorization method. What is prime factorization? You know it very well because we have been doing it from class 4, 5 and so on. So nothing to tell about prime factors, how to find out the LCM, right? So we have taken a number that is 64, a very common number, right? So 64, just find out the prime factorization or the factors of 64. You can see it is, we can take the least, that is the smallest prime factor, that is 2. 32, again 2, it's going with 2. 16s are again 2, going with 8, again 2 with 4, and 2 2s are 1. Okay, so here we are having 1, 2, 3, 4, 5, 6, 6 2s. So the factors of 64 are 2 cross 2 into 2 into 2 into 2 into 2. That means it can be written as 2 to the power 6, right? I have written in this broad way, in this classified way, so that I can make you all understand. We are doing square root. Square root means what? 2. The power is 2. So whenever we write 2, that means a pair of numbers will be taken. A pairs of the same type of numbers will be taken. So here all of them are same. All the digits are same here. So in that case, this will be a first pair, this will be a second pair, this will be a third pair. Okay, so from this 1, 2 will be taken. I have taken it. Again from this pair, I have taken 1, 2 out. And from this pair, we have taken another 2 out. So 2 cross 2 cross 2, we are getting the result as 8. So what is the square root of 64? 8. Now let me tell you one thing. If here only the root is given and particular number is given, suppose 81, okay? So that means this particular root implies it is a square root. But if suppose cube root of 27 is given, then obviously here third root, fifth root, sixth root, seventh root will be mentioned here. So accordingly this will be cube root of 27. That will be mentioned. But if nothing is mentioned, that means it is a square root. Okay, so very well you can understand from here. So this was a very easy method how to find out the square root of a particular number using the prime factorization method. But suppose there a number, or maybe at last we don't get 1. So in that case, that particular number may not have any perfect square root. May not have any perfect square root. Okay. Next. Now the next method is by repeated subtraction. We will take a particular number, suppose as A. Okay. A is a particular number. Now this particular number has to be subtracted from the odd numbers. Right from 1. 1, 3, 5, 7, 11, 9, 11, 13 and so on. As long as we get 0. Once we get 0, we will count the number of steps we have repeated that subtraction. So that becomes the answer. Okay, like I have taken for example 49. Okay, suppose we don't know what is whose square root, what is the square root of 49. So the first one, that supposing this to be the A, we are going to subtract evenly with all the odd numbers. So starting from 1, 49 minus 1 it's 48. 48 minus 3 it is, because from here we are subtracting again minus 3, we are getting 45. Again 45 minus 3 equal to 40. You can see 1, 3, 5, 7, 9, right? So 40 minus 7 we are getting 33. 33 minus 9 we are getting 24. Then again 24 minus 11 we are getting 13, and 13 minus 13 we are getting 0. I said as soon as we are getting 0, there our result stops. Now after getting 0, you can see that how many steps, you can just count the number of steps by which we have got 0. 1, 2, 3, 4, 5, 6, 7. That means within 7 steps we have got the result as 0. So that means root over of 49 we get as 7. That means the square root of 49 is 7. I hope this method is really very easy for you. This also, it won't have any problem. You can find out with any type of numbers, be it 324, maybe it is a long process, but you can do it. And the easiest one that we did was the prime factorization. Okay, this is also easy, but it's a bit lengthy. Next, coming up with other division methods. Now, next one is the long division method. Okay. So here we have taken the number 45796, 45,796. Now you can see that it is a odd number of digits. We have odd number of digits, like 1, 2, 3, 4, 5. 5 digits are there, right, in the number. So the first thing that we are going to do is we are going to group these out. Okay, we are just going to group these sums, the digits out. So first we are going to take it as a single digit, and then we are going to take as 2, 2, that is 1, 1 pair. Okay, these 2 pairs we have got. Okay, so remember always whenever we have odd number of digits, okay, first take the first one as single one and then pair the others. Okay, if you have already an even number of digits, then 2, 2 pairs. Okay, suppose you are having 1, 2, 9, 6, this as a number. Okay, so in that case you will group as 1, 2 and 9, 6 as 2, 2 pairs. Okay, here since we are having 5 number of digits, so the first one has to be left out, and then this 2, 2 each has been made into pairs. Next one is, you have to see whose nearest squaring number is 4. Now 4 itself is a square of 2. So we have simply written 2 2s are 4. If suppose there was 7, right? So the nearest squaring digit is what? Obviously 4 only, because 2 square is 4. Again 3 square is 9. So 9 is bigger than 7. So we will be taking up 2. So 2 square will be 4. Suppose here it was like this. 2 square is 4. So we have 3 left over. Okay. So take the nearest squaring digit. Next. So after this we have got 2 2s are 4. Here is I've just put cross, you know the division formulas, everything. We just subtract, we get 0. I've just put cross over there. Then this 2 pair is coming down, 57. Okay. Now what you need to do is, forget about 1 and 4 right now. This particular 2, okay, 2 2s are 4 that we have got. This particular 2 is getting multiplied with 2 and we are getting 4. 2 2s are is 4. How are we getting this 2 2s are 4? Okay. Now you have to take a digit in such a way that we get 57. Now the same digit I have taken 41, because 42 we have to multiply with 2 also. Okay, the same digit has to be multiplied. Whatever digit we are taking at the side of 4, we have to multiply with the same digit. So if we are taking 2 here, we have to multiply it by 2. So we are getting 84, but 84 is bigger than this 57. So obviously it needs to go with 1, because we are going to get 41. Okay, so this one has to be put in the quotient also. So we got 21 here and it is going with 41. 1s are 41. So I got 16 as the remainder. Okay, 16 as the remainder. Now as usual the process, 96 both together are coming down. Since it is a pair, it is going to come down because we are doing square root. 1696, okay, is the number now. Now next time we are having this 2 particular number, that is 21. So 21, obviously again this 42 is obtained from 21 into 2. Okay, so we got 42. Now we have to see with which number has it to be multiplied so that we get this particular number 1696. So after much of calculation, you can obviously whichever number will be kept at the side, that only has to be multiplied. So if I am taking 3, we are getting 9, 6, 1, 2, 6, 9. 1, 2, 6, 9 is not the number. Next, check up with 424 into 4. 4 4s are 16. Carry 1 here. So we are having 9. So 1696. Yes, this is the exact number. So 4 has been placed here and another 4 in the quotient. So we are getting 1696. Remainder is 0. That means the perfect square of this particular number or square root of this particular number 45796 is 240. This is a main important point where your quotient gets multiplied into 2 and that becomes your divisor in the next step. That is the most important part to be remembered in the square root division process. Now we have taken the decimal of a square root. Okay, we will be taking out the decimal number and we will find out the square root. Same process, nothing that tough. Okay, the next thing that we are going to do is remember one thing that I said, forget this part, the decimals part now. Now for this particular number, okay, 853. this is a obviously odd number of digits are there, like 3 digits are there, 8, 5 and 3. So I said leaving the first one, the next two has to be paired. So that's what I did. Now after the point, that is a decimal part, we have this particular number 456. Okay, that is also a odd number of digits, 4, 5, 6. But remember always, after the decimal part, we need to take pairs. Not single digit and then pairing up. No. So we will be doing the pairing, and then let's put a 0 so that we get paired up with it. Okay. We have put a 0 to make it a pair. So 4, 5 is one pair, 6, 0 is another pair. This is just after the decimal part. Okay. This is a decimal part. After the decimal, it is a decimal part. Okay, and before is an integral part, where 853 was an odd number of digits. I have taken the first one out and then 53 as a pair. Okay, next, the first thing, and if you already have, suppose after this, suppose you're having 8534561 as a number. So you can easily understand this has to be taken as a pair, this has to be taken as a pair. Okay, but in this case, since there was no numbers after this 6, it was an odd number of digits, I put 0 to make it as a pair. Next, same process, we have to find the nearest square number of 8. So it was 4 again and not 9. So 2 2s are 4. We got the subtraction or the remainder as 4. 53 came down. So now 2 2s are 4. This particular 4 is coming from the quotient and multiplied with 2. We are getting 4. Which number is getting multiplied with it? 9. So 49 nines are, we are getting 441. After subtraction you got 12. 45 is coming down, so we will put the point in the quotient. Now after getting 1245, you will see that we have 29 as the quotient. So 29 into 2 will give you 58, right? So 58 has to be multiplied with, or has to get with 2, so that it multiplies with 2 to get 1164, which is nearest to 1245. So after subtraction again, we got 81 here and 60 came down. Okay. Now in the quotient part, we have 29.2. That point we will not consider right now because we need a number in the divisor for the next division. So there comes this 584. Here comes 292 into 2. Okay, so 292 into 2 we get 584. We are multiplying it with 1 into 1 so that we get 5841. Here we get the remainder as 2319. This particular square root does not have any, that is, this remainder is still remaining because it's not a perfect square root. Okay, so this will be the answer. The quotient will be this and the remainder will be 2319. This is how we do our long division process in case of decimals. Okay, please repeat it once more. You can rewind it and see. Now this is the last method, estimate the square root. Okay, now we have taken one number 5322. Now for this number we will take the estimations, okay, within which number this is lying. So as we can see, that is 70 square is 4900 and 80 square is 6400, right? Now, so obviously you can understand that this particular is lying between 4900 and 6400. Okay, next let's come up to other numbers. 75 square, we are getting 5625. So now again we can see that this particular number 5322 is lying between 4900 and 5625. That means 70 and 75 squares. Okay, so we are taking 72 square, that is 5184, 73 square 5329. Now easily you can understand, you can work out with other also, that is 71 and 74 also. I have not done because I felt I could have done it. Okay, so you can carry out with this also for your convenience. So we got 72 square as 5184, 73 square also as 5329. As I got 5329, you can easily understand this is very close to 5322, right? So in that case, root over of, that is square root of 5322 is estimated as 73. So this is how the near about estimation is done. It's not correct, but it's a estimate. Okay, so this is how we that is find out the square root using the estimation. So this was all about square and square roots. I think you have understood all the main parts which I have covered. This will be there in your chapters. Please practice it. And so if you have not understood any part of it, please do comment, and if you have liked the video, please put a like, share and do subscribe, and please don't forget to press the bell icon because you will get many more notifications of the chapters. Thank you and have a good day.